Hello, welcome you to this session, that is 32 session. This is the second Fourier transform topic. In this topic, I am concentrating on examples of Fourier transform. Fourier transform is also called as a complex Fourier transform. So don't get by saying this name. Where is Fourier transform? What he is doing? So Fourier transform and complex Fourier transform, infinite Fourier transform are one and same. You are going to apply that same formula and get the result for it. Find the complex Fourier transform of the function f of x is equal to 1 for mod x is less than or equal to a, 0 for mod x greater than 0. Hence, evaluate integral 0 to infinity sin x divided by x dx. Right. The solution here, we are going to apply the infinite Fourier transform. So what is the formula? F of u is equal to integral minus infinity to plus infinity f of x e to the power iu x dx. Now in the given problem they have given less than or equal to a, but the actual formula is what it is saying, minus infinity to plus infinity. Now you have to break in terms of the interval is given for the function, that is a. So how I will break, you just see. This can be written as, I will start with minus infinity minus a f of x e to the power iu x dx plus minus infinity to a f of x e to the power iu x dx plus a infinity. Okay, here the third term, if you see the function, it will get as 0. Why? If f of x will be 0 when a is greater than a. So last third, whatever the integration third term is there, it will get 0 according to the function. And first one is also 0. What is that first term? That is minus infinity less than a. Okay, the first and last term is vanished. Only the term is left out is here. Integral minus a to plus a f of x e to the power I u v x. Right. Yeah, this is the what I just said. So now you know what is f of x in this limit, upper limit and lower limit. As we know, that is 1. Okay. Now when you do the integration for this, e to the power iux divided by ia. So now try to put wherever a is there, wherever x is there, upper limit and lower limit, and take out 1 by iu outside. Yeah, 1 by iu outside, e to the power upper limit I am putting iua minus e to the power minus iua. Now you know what we mean by e to the power iua. So just I try to put cos ua plus I sin ua minus cos ua minus I sin ua. So here minus and cos ua minus cos ua will get cancelled. We'll get 1 by iu 2I sin ua, right? So what is that one we will have here? F of u is equal to 1 by u sin ua. Now to evaluate integral 0 to infinity sin x by x dx, we know that f of x is equal to 1 by 2 pi minus infinity to plus infinity f of u. You already calculated what is f of u, capital F of u e to the power minus iux dx. This is an inverse Fourier transform is there. So just you place the value of capital F of u over here. So 1 by 2 pi minus infinity to plus integral minus infinity to plus infinity 2 into sine ua divided by u e to the power minus iux is there. Now how to do the integration? Now put x is equal to 0. When you put x is equal to 0, what will happen to this? Yeah, you will get this one as this upper limit in the integration. You just see constant part is 2 is there, that 2 and 1 by 2 pi will get cancelled there, so you got 1 by pi. Integral minus infinity to plus infinity sine ua divided by u. What happened to the exponent part? E to the power 0 is nothing but 1. Therefore exponent part is vanished, you got only du, right? So next step, what you will do, we know that sine au divided by x is an even function. So even function means integral values will change. Minus a to plus a will get as, now you just see, f of x is equal to 2 by pi integral 0 to infinity sine ua divided by u du. Right, so this is what the thing is, that f of x is equal to 1 as I said. So 1 is equal to 2 by pi integral 0 to infinity sine u a divided by u. So if you transfer this one to the left hand side, you will get pi by 2 is equal to integral 0 to infinity sine ua divided by u du. Okay, so pi by 2 is equal to, put a is equal to 1. So if you put a is equal to 1, we will get pi by 2 is equal to integral 0 to infinity sine u divided by u du. Now, what is that one you will get? So pi by 2 integral 0 to infinity sine x divided by x du. Next problem, find the infinite Fourier transform of the function f of x is equal to x. Okay, so let me try to do. F of u is equal to, this is a known formula, minus infinity to plus infinity f of x e to the power iu du. Once again same strategy I have applied. Minus infinity I started, minus infinity to minus alpha to plus alpha, alpha to plus infinity. So here the first and last term will get as 0 because of this whatever the given situation over here, only middle one will contribute over here. Yeah, f of u is equal to minus alpha integral minus alpha to plus alpha x e to the power iux dx. Now it is an integration by part you can apply, or Bernoulli's rule of integration you can apply. Anyhow, I have used Bernoulli's rule of integration. So I kept first x as it is, and I done the integration of e to the power iux. E to the power iux is nothing but you will get as e to the power iux divided by iu minus, once again if you do differentiation of x will be 1, right, minus e to the power iu divided by, one more time I will get e to the power iu whole square. Now apply the limit for this. If you apply the limit for this, what is that limit you will get here? Yeah, upper limit I took outside for the iu outside. Wherever x is there, I will put upper and lower limit over here. So alpha e to the power upper limit I am putting first, alpha e to the power iu alpha plus alpha e to the power minus iu alpha. Okay. Yeah, one mistake has happened over here. That middle in between the lower limit, it should be minus, it should be uh, in first term I have wrote as positive by mistakenly. So 1 by u square, what happened to this minus means I square and minus, it will get as minus into minus, it will get plus. So 1 by u square e to the power iux and minus e to the power this one. Yeah, once again if you apply whatever the e to the power u alpha is cos u alpha plus I sine u alpha, so cancellation will happen. After cancellation, we will arrive at the result as alpha by iu 2 into cos u alpha plus 1 by u square 2I sin u alpha. I hope you got my things. Thank you.